Math 2414, integration by parts, example 2. Integrate the natural log of x dx. This is a stealthy integration by parts problem because the motivation for considering integration by parts is remembering that parts means parts of multiplication problems. This integrand doesn't seem to have many parts, but every integrand has at least 2 parts. Something you're integrating, which might be as simple as the number 1 and a dx. So every integral will have at least 2 parts. So every integral can be considered for integration by parts. That doesn't mean it'll always work, but it's always an option to consider. All right, if we're going to do integration by parts, just a reminder, we have to start by taking the integral that we're given and viewing it as the product of 2 parts. One part as a function that hasn't been differentiated yet, and one part as a function that has been differentiated yet. All right, so let's start by choosing the u and the v. By choosing the u and the dv. Now, one thing I can say about the dv is it always contains the dx, or whatever the differential is over here. So we can automatically file that under the dv. But what about the rest of the parts? Well, the only other part we haven't accounted for is the ln x. And I actually have a choice on where to put it. Either I can put it over here with the u, or, let's see, erasers are good, or I can put it with the dv. And you might be wondering, well, wait a second, if you put it with the dv, I know there's an eraser here somewhere, there it is. If you put it over here with the dv, so ln x dx, what would you put over here for the u? Well, there's always a factor of 1 to be considered. But I wouldn't run with this, because think about what would happen as a consequence of putting everything in the dv package and leaving only a 1 for the du. If you took the derivative of the u, it would be 0, and it would kill this integral. And to find the v, you would have to integrate natural log of x, which is the problem we're trying to do in the first place. So here's a minor something that I think it's worth mentioning. When you're doing integration by parts, you never want to put everything in the dv. Because if you do, then you still have to integrate the original thing, and you haven't gotten anywhere. So if you consider all that, the dx must go with the dv package, but you never want to put everything with the dv package. Then I only have one choice, and that's put the ln x over here. Which I don't mind doing, because the u is what I'm going to differentiate, and I know how to take the derivative of natural log of x. So let's use this setup and see what happens. If we let u equal the natural log of x, then du is equal to the derivative of natural log of x, which is 1 over x, times dx. That wasn't too bad. And v, well, actually v is just the integral of whatever dv equals, but the integral of dx, remember that's like integrating the number 1. What do you take the derivative of to get 1? X. And now we have all the pieces necessary to rearrange the original integral into this difference. So, the original integral, the natural log of x dx, is equal to u times v. U is natural log of x, v is x. So if we multiply u times v, we get natural log of x times x. But don't ever write stuff after a natural log if you can avoid it. As a multiplication problem, it would be cleaner if you put the x in front of the natural log of x. So u times v, or in this case v times u, minus the integral of v. V is just x. du. du is 1 over x dx. And integration by parts has done its job. It's changed the integral into a different expression involving a different integral. Let's see how it concludes. A constant reminder, even though I don't say it all the time, you are welcome to and even encouraged to stop a video to see if you can get to the answer before I do. So even when I don't say, pause the video and try this problem, you should think about it and do it as often as possible. All right, let's continue. No double negative like in the previous example, so it's still a minus. But we are multiplying x times 1 over x. Those are reciprocals. They cancel each other and leave just a 1. So really it's just the integral of dx again, just like we had here. And the integral of that is still just x. Plus a constant of integration because it's an indefinite integral. And we seem to be done. Now we didn't check the previous answer because I knew that we were going to do the definite integral afterwards, stretching the video out. But I do want to check this one just to convince you that I'm not blowing smoke. So if we check this, we have to take the derivative of what we claim is the answer. The derivative of x times the natural log of x minus x plus c, and see what that equals. Well, the derivative of the constant is 0, so I don't have to worry about that. But the x times natural log of x is a product and therefore invokes the product rule. So let's execute that. Product rule here, the derivative of the first, the derivative of x is 1, times the second, so times natural log of x, plus the derivative of the second, derivative of natural log of x is 1 over x, times the first, so times x. And again, all this is just the derivative of the product. Now we're at the minus x, its derivative is minus 1, and of course the derivative of the constant is 0. And let's clean this mess up. We have 1 times natural log of x, which is natural log of x, plus, here we have 1 over x times x, which is 1 again, minus 1, plus 0. Everything vanishes except the natural log of x, which is what the original integrand was. So it is a correct antiderivative, and it worked. All right, so integration by parts. Doesn't do an integral, it simply changes it to a different integral.